So today's problem was you have a birthday present and you need to wrap it. Here are the dimensions of the box, and I've drawn it out for you. How can we solve this problem of how much wrapping paper this present will need?
So we drew a net, and how we did it was we had the measurements that were a meter, 30 centimeters, and 45 centimeters. So we put that onto the net, and then we decided that this would be 30 centimeters. So if this is 30 centimeters, it would be the same. And we wrote 1 and 1 to signify that they're identical. These two faces are identical, and these two faces are identical, and these two faces are identical. So all you have to do now is find the area of one of each rectangles. So we did that. So for the first face, is 30 centimeters. Centimeters squared because it's the area. And then you would just multiply that by 2 because it'll save you the step of adding all of them, adding more in the end. You can do it twice if you want, but we just did it times 2.
So those two, you're saying that
they're identical.
They're congruent, right?
Yeah, they're congruent. So then the second face is not 30 centimeters, it's 45 centimeters because from here it's the same. Mm-hmm. So it would be 45 centimeters times 100 centimeters because the 100 is here on this line. And then we multiplied that by 2 because there's 2 of the same one. And then for the third one, it's 45 times 30. 45 times 30 centimeters. And then multiply that by 2. So then, and then you would add the sum. So and then that got us to centimeters. Yeah.
Okay.
That's how we found it.
Now, I like how this group broke up the squares or the rectangles to tell us which ones are congruent, because it really cut their work in half. Okay, and then here's another one. Okay, now what did they change in this information? They changed something. What did they change? They made a minor adjustment. Because if you could see from the top, those are the dimensions. They made a little tweak. Why do you think they changed, or why did you change all the units to centimeters? You're saying it's possible for it to be all in meters or all in centimeters, but they can't be mixed. So right here, you would have 1 meter. If you multiplied 1 by 30, your answer is going to equal 30. But we know that it's 1 meter is 100 centimeters. So if I were to take all these calculations here, so I'm going to just rewrite the calculations. So let's call this box 1, box 2, box 3. Okay, because there's 1, 2, and 3. So the first one is 100 centimeters times 30 centimeters, correct? So what is 100 centimeters in meters? Tahir. 1 meter. What is 30 centimeters in meters? 0.3. So 0.3. And if you multiply 1 by 0.3, what is your answer? 0.3. And since there's 2 of them, multiply it by 2. And what answer is that going to give me? 0.6. Okay. Let's look at the second square now. We have 100 centimeters multiplied by 45 centimeters. How can we convert this? 100 centimeters we said is 1 meter. And then 45 centimeters, what is that in meters? It's 0.45. This is almost the exact same thing we did with percents and decimals, right? So it's probably a good thing we already did that. 1 multiplied by 0.45 will give us an answer of 0.45. And since there are 2 of them, multiply by 2 equals, correct me if I'm wrong, it's 0.9, correct? Okay. The last one, we had 45 multiplied by 30. So this rectangle here. Okay. So if we had to convert centimeters to meters, the answers are actually right here on the page. But what is 45 centimeters in meters? Leah? 0.45. And what is 30 centimeters in meters? 30 centimeters. Sinan? 0.3. Okay. And when you multiply these together, you get 0.135. Multiply this by 2, it gives you 0.27. So now that we have all these calculations in meters squared, we had them all here for centimeters squared. They added them. We can do the same thing. 0.6 meters squared, 0.9 meters squared, 0.27 meters squared. So when you add them up, that 7 stays. This becomes a 7. This becomes a 1. So 1.77 meters squared. So now you should make a little connection here. Because we know that 1 meter equals 100 centimeters. But now we're working with squared. My question to you is, 1 meter squared equals what? Ibrahim?
10,000.
It's 10,000. Because if you have 1 meter squared here, there's 10,000 here, because there's 17,000. So basically, 0.77 meters squared is equal to
7,700.
correct. 7,700 centimeters squared. So now this is a little tricky because you know that 1 meter is 100 centimeters. But 1 meter squared is 10,000 centimeters. So I'm going to show you what he just said in the form of a drawing. Pretend we have a square. Here's our square. This is 1 meter. How do we find the area of a square. What is the area of a square? What's the formula? It's length times width. And in this case, it's a square. Who cares what the length is? Who cares what the width is? And it's 1 times 1, correct? 1 times 1 equals 1 meter squared. Now, let's redo this same drawing. Same drawing, identical drawing. But instead of me putting this in meters, I'm going to put this in centimeters. 1 meter is how many centimeters? It's 100, right? Okay. Area is length times width. Area is 100 times 100. 100 times 100 is 1 with 4 zeros. 1, 2, 3, 4 centimeters squared. This is why it's such a big jump. It's a huge jump from meters to centimeters and meters squared to centimeters squared.